Hi, everyone. So I want to start off and basically talk about, there is a movement underway in many circles to transform the way classroom instructors approach teaching mathematics. And the basic idea is to create an environment where students are forced to think because the class experience is structured in such a way that they have no choice. And the result of all the thinking, they learn more and they do better at math. And the shift and the dialogue that has emerged around it is largely due to the book, Building Thinking Classrooms in Mathematics, which was published in 2017 by Dr. Peter Liljedahl. Now, Dr. Liljedahl's research, which served as the foundation for this book, was born out of observations he made after visiting 40 different math classrooms in 40 different schools, from kindergarten to grade 12. And what struck him was a common theme. No matter the level, he saw students not thinking and teachers planning their teaching on the assumption that students either couldn't or wouldn't think. So over the next 15 years, he and his team worked with math teachers for the singular purpose of finding and tweaking the levers that would increase the number of students that think and the amount of time they spent thinking. The result of the research are 14 practices that, when used together, build a thinking classroom. Because thinking is a necessary precursor to learning. And if students are not thinking, they aren't learning. Now, these practices are being successfully applied in thousands of classrooms from kindergarten to grade 12. And today, I'm here to show you how you can apply many of these practices to get similar results when teaching at the college and university level. So as Rochelle mentioned early on, my name is Karishma Panwani, and I'm the Director of Academic Product Management at Maplesoft. And over the past decade, I've collaborated with educators and students to ensure that the tools and solutions they have truly cater to their needs. Now, throughout this journey, I've had the opportunity to see what is working for instructors and their students, and more importantly, engaged in meaningful discussions about what isn't. And it will come as no surprise to anyone that teaching math at the college or university level, whether it be in person, online, or a combination of both, comes with, let's say, challenges, a lot of challenges. But I'm convinced that when it comes to learning, we can make the experience better. I believe that the framework detailed in the Thinking Classrooms book, when combined with the right software tools, can help us get to the same levels of learning, critical thinking, and engagement that we are actually seeing at the elementary and high school levels. So as I mentioned earlier, the Thinking Classroom framework outlines 14 practices for fostering thinking and learning. All of these practices are important, and the background behind each of the practice is explained in detail in the book. However, the ones that I believe that will be the most transformative for students at higher ed institutions, based on my interactions with educators, are those listed from numbers 3 to 11. Now, I won't read all of them, but here are a few highlights. Practice number 4, encourage giving tasks verbally rather than in writing, and have students do a task within the first 5 minutes of a lesson. Doing this has been shown to produce significantly more thinking and different types of thinking than giving the same task later. Practice number 5 basically states that if we want students to think, we need to give them something to think about, and suggests that the best way to develop a culture of thinking is to present students with highly engaging non-curricular tasks upfront, and then transition to curricular tasks later on. Practice number 6 argues that to really access the potential of a thinking classroom, students need to learn to look at the work of their peers, to make use of the knowledge that exists in the room, and to mobilize that knowledge to keep themselves thinking when they get stuck or when they need another challenge. Now, at this point, you're probably wondering how you might do these things in a large classroom setting, an auditorium setting, or when you're teaching hybrid or online. Oops, skipped ahead. So what I want to do for the remainder of this webinar is I want to look at some examples and give you some resources and tips on how you might employ some of these practices into your classroom. So let me pause this video first. So here I have a video. And in this video, you'll see how an instructor, in this case, played by Jane over here, presents her students with a highly engaging non-curricular task. So a few things that I want you to notice as we watch this. Let me skip back a little bit. Now, before the task is given, Jane divides the students into visibly random groups. And in this case, she's just using an online random group generator software. And so one of the things the book talks about is that the formation of the groups should happen in front of the students. This assures that the groups are indeed random, and this convinces them that the groups are random. And the book states that this is important because when groups are random and students believe that they are in random, students begin to see themselves as valued contributors capable of mathematical thinking. Oh, my slides are just going ahead. Let me pause here. So right now, so we have Jane, she's divided the groups up into random groups. Now we're going to continue watching this video. Jane over here is going to go ahead and introduce the task, in this case, solving a nonogram puzzle, verbally. So she's explaining the task verbally, and she's getting the students to become engaged and involved by asking questions, the answers of which she's jotting down in Maple. So we can see that over here. I don't know why it's jumping around so much today. I apologize. Okay, so one thing that I want to mention over here is that the nonogram task is a perfect example of how verbal instructions lead to quicker uptake than written instructions. And it took me several minutes to understand how to play the game when I read the instructions, and only a few seconds to understand the rules when they were explained to me verbally. And this is true for most people. At this point, after all the students understand how to play the game and the instructions are just kind of jotted down in the document, Jane will go ahead and start some breakout sessions. So you can see that over here. So these are the groups, and then she's going to initiate some breakout sessions. So one thing to note over here is that the students have autonomy to join another breakout session if they have questions or get stuck. Now, I'll get into this in more details later on. So in this next part of the video, the students, in this case, Jane and Laura, and Jane now, for this video, has gone from being a teacher to a student, are collaborating together in a Maple live session. So these two students are working together to solve this nonogram puzzle. And while the video makes it appear as if Jane is sharing her screen, that's actually not what's happening over here. In this example, each student is looking at the same document on their own screens, and any changes that either of them make are being reflected immediately. When the session is over, each of them are left with a copy of what was done. And so then this allows Jane, if we go back over here, this allows Jane to make any notes to her future self, and Laura can do the same thing. So this is one example of, how a non-curricular task and group work lead to better or thinking for longer periods of time in the classroom setting. Now, in the last video, I demonstrated how engaging students in solving a nonogram puzzle serves as an excellent illustration of non-curricular tasks. And there are many such activities to choose from, both in Maple and Maple. So here's one that I wanted to show. You might be familiar with this. This is the bridge and torch problem, where the goal is to get a group of friends, 4 friends, with one flashlight across a bridge in 15 minutes, given that the bridge can only support 2 people at the same time and that each friend walks at a different speed. So you see over here, this is another great thinking activity that students can do. And it just primes them to approach problems with that mindset. Here's another one, the 15 puzzles game, where the goal of the puzzle is to arrange the blocks sequentially from 1 to 15, with the empty block, which would be number 16 if it were there, in the bottom right. So I speed up this video considerably because it did take me a little bit of time to do. But this is, again, another great activity of a non-curricular task, which students can get to start getting excited about learning and about thinking. And then the last one I want to show over here is the 4-color theorem puzzle. So this puzzle over here, there's a bit of background of what this visualization and what the theorem states, but really the goal is to color the map at most using 4 colors so that no 2 adjacent regions have the same color. And a great way, this again, a non-curricular task, but it can also be used to kind of prime the discussion when looking at this theorem or going into detail about this concept. And then I'll keep playing it. And you can always click to reveal the answer. So those are just 3 examples. If you want more inspiration, I encourage you to go ahead and take a look at all of the resources, both in Maple and MapleLearn. So I'm going to skip ahead. And now let me pause this video. Oh. So in this next video, I want to show you how an instructor can mobilize knowledge, particularly in a virtual setting. And so one of the things that the Thinking Classroom framework states is that, or encourages, I should say, is that students look at the work of others when they are stuck. And this is how knowledge is mobilized across the classroom. So this is easily accomplished in kind of small in-person settings by having the groups work at whiteboards or other vertical non-permanent surfaces spread around the classroom. But how does it translate to the virtual classroom? How does it translate to large auditoriums? And so I wanted to talk about one way and one feature that you could take advantage of. So MapleLearn has this concept called live session. So an instructor can go ahead and create a live session for each group. And you saw me doing this in the previous video where Jane and Laura were working together. They were working together. They were collaborating through a live session. And basically, in this case, what happens is an instructor goes ahead and creates all of these live sessions for each group. So you can see on my screen, there's a link for each different group. And what happens is the students have access to this document, and as a result, have access to the live sessions of all the other groups in that particular classroom. So whenever a group gets stuck, they can always go in and just join the live session of another group. So in this case, you'll see over here, each group begins by working on their own respective live session. So this is a group working on it, or a single individual is working on their own live session. So you see over here, our student is trying to solve this, gets stuck, as Jane is in this video, and then they have the autonomy to look at another group's live session. And they can even join the breakout session as well if they want to have questions or have discussions. So in this case, Jane looked at what her peers had done. If I scroll back a little bit, and then was able to realize that the problem was more easily solved if they graph the particular function. And so you see that that's what they're doing over here. So this is how one can kind of mobilize knowledge in a virtual or large classroom setting. The problem can be any problem. In this case, it's an integration problem, but whatever activity you want to choose, you can use this to encourage collaboration and encourage or mobilize knowledge. Now, finally, the Thinking Classroom framework recommends that instructors rebrand homework as check your understanding questions. I'm going to pause this over here. Which are not graded or checked for completeness. Now, this is because many students perceive homework as something for their teachers and for grades, and not for them to check their understanding. So by changing the language we use and positioning these questions as an opportunity rather than a requirement, the research saw a significant improvement in how students engaged with the practice. Now, in the last video, I wanted to show you how students could use Maple, or I should say in this last video, I want to show you how students can use Maple and MapleLearn to check their own understanding when working on their own. So in this first example that I have over here, Jane uses MapleLearn to get meaningful feedback on why her initial answer of 136 or square root of 136 was incorrect. Let me go back over here and you can see. So initially she said that it was 136. And then if you see, she clicked on check answer and she got some feedback on why that was the incorrect answer, giving her the ability to go and update her solution. Here's another example. So in this example, Mike, our student, is interacting directly with a plot in Maple to get feedback on whether his line corresponds to the equation given. So we have this equation, and the question is to graph that equation in this plot window. We can click on grade and get some feedback and get the new line, or get another example to practice on. So again, clicked on new example and can go ahead and try again. Now, at any time, Mike or any student has access to the full power of these tools. So if they want to do a side calculation, so practice, ask for resources, all of that is available to them. So when they're doing their homework, which invariably happens, the night before it's due at 2 in the morning, they have resources that they can get to in order to gain confidence and get help. So here's another example over here, and I'll pause it. So in this example, Mike is going to use the differentiation methods tutor to get guidance on differentiating his chosen expression. So over here, you'll see he enters in a new expression and he can start. And he can then go ahead and just, the job over here, or the goal of this tutor is to say, does he know which of the rules to apply? And so here he clicked on sum and he can go on. Power, he can get a hint if he gets it incorrect. At any point, he can click on, oops, if we go back, next step, if he's really stuck, to get the next step, or all steps. So Maple comes with many different tutors and resources. You can find them all under the tools menu. And so Maple also has student packages for calculus, multivariate calculus, vector calculus, pre-calculus, statistics, so on and so forth. And so there's an abundance of resources that students can take advantage of in order to solidify their understanding and practice a concept. So here's another example that I wanted to show. And what I wanted to talk about here is that how math at a higher level can be fun. So you'll notice over here, this is a color by numbers document. And a lot of us, got these when we were in elementary school. But there's no reason that we can't apply this game or this concept to higher level topics. In this case, I chose someone about differentiation. And so similar to the differentiation methods tutor that you saw earlier, the goal of this document is, again, the same thing, to make sure that the students understand which of the different rules they should apply first in order to solve this problem. And so you can see over here, Jane is kind of just working through it and is getting feedback each time she colors a square. One thing to note here is we've had a number of different instructors use some of these resources kind of as well as a refresher, either in classroom, to say, okay, I expect you to know this particular concept, or sometimes even outside of classroom time to say, make sure to, play this game or use this tutor in order to make sure you're ready to come in and start learning the next topic. And so this one was a Halloween themed one, and you'll see it turns out to be a pumpkin. At any point, if a student needs practice, they can go ahead and try another. So here, the other thing I also wanted to show as we move forward is how Maple Learn and Maple itself also includes support for manipulatives and other learning resources. So in this case, this is one about completing the squares, but I wanted to show that you have access to algebra tiles and can use these in order to solve the particular problem. And lastly, one of the things that I wanted to show is the support we have to give students the ability to check their own work. So in this particular example, student, this case Mike, is going to head and working through these problems line by line. In this case, Maple Learn is going to go ahead and analyze their work and give them feedback on where they might have made a mistake. So Mike is going, and you'll see he's using the Maple oops. Where did we, so let's try that again. He's actually, in this case, using the Maple calculator to take a picture of his handwritten solution and upload it into Maple Learn. So here he's going ahead and he's using the Maple calculator. It's a free mobile app. And he's going to go and take a picture of his handwritten work. That's his solution. And as soon as he does this, he's able to then import that work straight into Maple Learn. So that's what it is. He clicks on it. Now he's able to use this check my work button, and it'll analyze his work and give him feedback. And this gives him an opportunity to go ahead and correct his mistake. So you see he's updating his solution, clicking on check my work again, and same thing. And here's another example. And one of the reasons we did it like this is, we added this feature is because a lot of students like to work on pencil and paper. And so here they can continue to do that, but still then take advantage of the software in order to get feedback, meaningful feedback on where they might have made a mistake. And Check My Work works on all types of different math. So if you're doing integration, differentiation, working on solving equations, factoring, so on and so forth, you can use Check My Work and it'll give you feedback. And one of the things that we're working on is constantly improving the amount of types of problems that Check My Work can handle, as well as the amount of feedback and the types of feedback that it's able to give students. So I know I went through this quite quickly. I wanted to make sure that we had ample time to answer any questions. But what I wanted to do in this webinar is show you how the Maplesoft Mathematics Suite could really be used to help you transform your math classroom into a thinking classroom experience. So if you want to learn more about the Maple Mathematics Suite, please feel free to ask questions. I'm here until the end of this webinar. You can also email us. The suite consists of Maple, Maple Learn, Maple Flow, and Maple Calculator. And so we have online, desktop, and mobile solutions that cover math from high school all the way to graduate school and beyond. And it really is suitable for math courses, as well as subjects that make use of mathematics. So engineering, physics, chemistry, business, and economics. And we have tons of different resources. Moreover, if there's something that you're looking for or looking to create in any of these tools, feel free to contact us. We have a content team that helps kind of build some of these documents or supports educators in creating their documents, and we'd be happy to help you.